Hi, Science 30s. So here's a little video on what we call halogenated hydrocarbons. So this is our first look at sort of adding something to a simple hydrocarbon or a simple alkane. And one of the things we can add, or one of the what we call functional groups that we can add to an alkane, are halogen atoms. You guys might remember your halogens are your group 17 elements. And the four that we're going to be concerned with, or we're going to see here, are fluorine, chlorine, bromine, and iodine. And so those elements are in group 17, and that means they have 7 valence electrons. So if I draw a Lewis diagram of, let's say, chlorine, it's going to look like this: 1, 2, 3, 4, 5, 6, and let's put one over here, 7. And so what I see here is chlorine is very close to being at that nice number of 8 valence electrons to be happy. And it only wants to make one bond. So it's actually very similar in a way to hydrogen. Both of these have a bonding capacity of 1. So on an alkane, like let's say ethane. So here's a little Lewis structure of ethane, C2H6. Instead of being surrounded by hydrogens, some of these hydrogens can be replaced with halogens. So let's say I got a chlorine there, I got a fluorine, I got bromine here, I got iodine here. And now I have created a new molecule with new chemical and physical properties. And a lot of these halogenated hydrocarbons actually are pretty nasty. And one, for example, is what we would call a CFC, or a chlorofluorocarbon. So this would be a carbon that, instead of being surrounded with hydrogens, it may have some chlorine and fluorine scattered in there. And so the reason why CFCs are bad is actually when we produce CFCs come from old refrigerators, and I'm not going to write that anymore. So old refrigerators, they're used as a coolant. They also are used as a propellant for old aerosol cans. And we use these extensively. And what happened is they floated up to our upper atmosphere. It's called the stratosphere. And what happened up there is there was a series of reactions that happened with sunlight that produced chemicals that would react with our protective ozone layer. So we actually start to see that our ozone layer was breaking down. And so if there's less ozone, then we are getting exposed to more UV, because the ozone layer protects us from some of the UV rays that come from the sun. And so we would start to see damage to ecosystems. We know UV rays can cause cancer. They're ionizing radiation. So that altogether was quite bad. And those are chlorofluorocarbons, CFCs. Now, some other halogenated hydrocarbons, you may have heard of some of these before. We have ones that are called PCBs. Maybe that's one of these that you've heard of. These can also cause problems in ecosystems. And so POPs, persistent organic pollutants. So they're organic molecules that are pollutants, and they're persistent. And what that means is they don't break down in nature. So what happens is when these get into a food chain, they will magnify as they go up the food chain. And we've talked about biomagnification in the food chain before. And so these are things that would bioaccumulate in living tissue, and they would biomagnify as they go up the food chain. So all kinds of nasty things. Now, in the regular course, we would learn how to name these, but that's something that I pulled out of the sort of condensed version that we're doing online here. And so we just want to be able to recognize a halogenated hydrocarbon. So we're looking for these 4 atoms from the halogens being inserted in place of a hydrogen in an alkane molecule. Okay, so I hope that helps you guys. I'll talk to you soon.